thank you for coming. And I just want to say a few words about INGV. First of all, nice to meet you. I'm Vincenzo, and I work here as a research scientist, data scientist at INGV, and I'm also one of the organizers of PyData Roma Capitale. And what do I want to tell you about INGV? This is an acronym which stands for the Italian Istituto Nazionale di Geofisica Vulcanologia. So as you can imagine, this is an institute of a public research institute about geophysics and volcanology. This was founded 25 years ago. And pretty much in this institute, we study a great variety of topics ranging from seismic and volcanic risk, geophysics in general, the evolution of our planet. So anything that you can imagine dealing with the Earth and the Earth environment probably studied at INGV in Italy. And well, just a few words about our mission. So the main role, the main scope of having National Institute of Geophysics and Volcanology, it's flipping all the way around. Okay. Oops. I don't know what I did again. Puoi rimettere là. Ma cosa faccio che stacca la condivisione?
No, niente, questo.
It's my love for MacBook. Ok. So essentially the mission of our INGV is studying, as I told you, modeling the natural geophysical and volcanological processes, but we do a lot of stuff. So we study earthquakes, also climate and climate change, space weather. I don't know if anyone ever heard about space weather, and a lot of stuff. We are more than 1,000 people, researchers, technicians, and we are spread over different units across Italy. And essentially, on a global scale, INGV is divided into 3 departments. Each one is specialized. First one is specialized on earthquakes, and we have a department studying volcanoes. And the last one, which I belong to, and also my colleagues belong to, is the environment department, which deals with anything which is not earthquakes and volcanoes, essentially. So at our department, we study things ranging from geomagnetism and paleomagnetism, a lot of stuff. In particular, we deal with space weather, the interaction of whatever starts from the sun environment, travels through the interplanetary medium and reaches the Earth, the near-Earth environment. We do polar stuff, geochemistry, other things. In particular, in the unit that we are working in, we study ionosphere, which, just to let you know, it's the upper part of the atmosphere, which is ionized, and we use it for a lot of stuff like HF communications. In general, it's quite useful to study it and to know how ionosphere behaves when there are geomagnetic storms, for example, because this can disrupt the GPS that you use on your telephone, or high frequency communications that are used just to say when you are doing transoceanic flights. So that's the reason why we have to study space weather, and that's why we do it at INGV. That's pretty much the introduction that I have. And now I wish to tell you about the communities that we have this evening. I'm starting with PyData. Se mi puoi mettere la presentazione, che non so come fare. Dove ce l'hai? Okay. Now again, that's me again, wearing the hat of PyData Roma Capitale organizer. Welcome to the June meetup, taking place at INGV. Okay, first of all, who is here for the first time? Okay, I spotted some familiar faces and also some new guys. So, PyData is backed by NumFocus, which is an educational program, okay? And it is a no-profit organization based in the US, but it has a good reach worldwide. And essentially, the mission of NumFocus is fostering learning opportunities for developers working with open source tools. And that's why it is funding PyData, which helps in this kind of things and this kind of meetups on like local meetups taking places all over the world in each major cities. And NumFocus and the PyData community is essentially behind a lot of good and famous libraries that you probably use in your day-to-day work. So you can imagine like Jupyter notebooks, pandas, SciPy, whatever. Pretty much there, you're going to be sure that there's NumFocus and PyData behind that. And who we are? We are PyData Roma Capitale, which is the local chapter of PyData based in Rome. And this is us. We are the organizers. There's me, Vincenzo, Egon, which is over there, and Carmela, which is supposed to arrive like in a few minutes. And since like a few days, thanks to Egon, we also have a new website. You can reach it here. And from now on, you can basically use this website as a collector for any kind of information to see the upcoming events, to sign in on Meetup, or if you have a talk to propose, now you have a button for that. It's as simple as that. And we just hope that you enjoy and enjoy also this evening. Thank you very much. Now I leave the floor to Federica, which will introduce us about the RLadies in Rome.
Thank you very much. Okay. Okay, thank you very much for having us here today. So it's such an honor to be here at the INGV. So it's an important institute. So we hope to be able to pass through everyone here that is following today the importance that R has for us, and how do we work with this software. So RLadies Rome is a community just as the same as PyData. And within this community, we'll love to share open learnings. And we are not use just R, but we are open to learning other languages. As you can see here, this is our logo. And we are, I'll tell you a bit more about who we are and what we do. But I'd like to introduce you to a new group that is just starting here in Rome. And it is Rome R Users Group. And this is a new group that is born to meet us in person, just to share our interests, talk about this growing tech community. And so stay tuned, because we are going to post some new events, possibly in person in Rome. So you are very welcome to join us. Everything it's on our website here at RLadiesRome.org. So just, okay, this event is started. This is a procedure that we do because we as RLadies, we are committed to a code of conduct. And so just to advise you that this talk and all this sort of conference, I think, will be is recorded and will be posted on our YouTube channel at RLadies Rome here. And so why we do this? We do this because we are mainly meeting online, and our community is an international community. And so we do this to ensure a safe and inclusive and harassment-free space for learning. And we are committed to providing a respectful environment where everyone feels welcome to learn, connect, and grow. And so just if you like to learn a bit more about this code of conduct, you can go to this webpage at rladies.org/coc. Who we are? So we are a community of ladies. We are not, so we are gender friendly. So we welcome everyone. And within the years, this community has been founded in 2012 by Gabriela De Quieros. Has grown a lot, so becoming a very so well-spread community, just of ladies. So are called RLadies. We now have like 108,000 plus members, 247 groups within 68 countries. And what is RLadies Rome? RLadies Rome is, just to show you here, it's a local chapter of RLadies Global. And we are dedicated promoting continuous learning within the open source community. And we usually organize monthly meetings and we discuss current trends, mostly in R, obviously, but even other hot topics such as Python. Before to get into the talk that I want, the discussion I want to share with you today, I'd like you to see a bit more about what we do. And as you can see, RLadies as Rome here is shown in numbers, has grown a lot since 2023, so just 2 years ago. We are now widely recognized within the international community online, and we have 1+ members on Meetup, gained 2K plus reservations, and successfully organized more than 25 events. This is us. There is more people join us soon, so stay tuned and we will present more about our team. I can mention a few, just Claudia Vitolo. She's the co-founder of RLadies Global, and she did such as a kickstart for setting up this RLadies Rome community. And we also have an international team. And so you can propose a talk or be a speaker of RLadies Rome. As I said, we'll be happy to hear about Python as well. Okay, so today what I love to share with you is the passion for coding and coding languages. And so we are not just using R, but we also use Python. And what are the main, I haven't introduced myself. So I am the organizer of RLadies Rome. My name is Federica Gazzelloni. And just to give you an idea of what is my specialization, because I am a statistician. So this is most probably the main reason why I use R. So just a bit of, as I said, my specialization, my background is statistics. That's why I use R, because R is a specialized tool for statisticians. What I do is public health analysis, and I also have a background in actuarial science. Actually, I am an actuary, fully qualified. What I'm passionate about is continuous learning. So this is why I organize this workshops, these tutorials, and these meetings. I also teach some other environments. And today I like to share with you my learning journey. When you start learning a language, important is to have some sort of computational thinking, have language adaptabilities, and an analytical mindset. And these are basically the core skills that allows you to switch within different coding languages, or more importantly, focus on what you think is the best tool to use for your analysis. And here is a fun things that I like you to share with you. So let's hear what he's saying.
Python is an open source programming language commonly used in data science. Which one should you be using? At this point, you might be expecting a fence-sitting, well, depends kind of answer, but no, I'm going to tell you exactly which one to pick right now. So here goes. I ask you a question, and based on your answer, you'll know which language to go for. Ready? Okay, so do you have much in the way of programming experience? None use R. Some go for Python. Lots R again. I'll explain. Okay, question 2. Do you care about awesome looking visualizations? Yes. R. What about the problem you're trying to solve? Machine learning stuff, go with Python. Finally, what do most of your colleagues use? Use that.
So this is just a minute, and it tells a lot. So here at the Institute, the National Institute of Geofisica and Vulcanology, I suppose you make maps. And so I enjoyed many competitions, one in particular, which is this 30 days map challenge. And I did lots of maps, in particular in R. So data visualization, it's one of the key features that R provide. And so if you like to learn more, you can learn more and doing amazing maps with R. Oops. So what R and Python together provides lots of advantages. We can see that there are different type of analysis that we can do, and for this reason we can choose and switch between languages. So R offers extensive statistical packages. Python is more versatile, and so, as I said, within the web you can integrate and obtain good tools, but both languages are very strong and support the work that the community does. You can relate to both languages, so you can use Python with R using reticulate package, and you can use R from Python with rpy2. So it's important that for real world application, we can use both languages. And just to give you an idea of something that I really like it, few differences within them. R, for example, was born in New Zealand by Ross E. Haka and Robert Gentleman, while Python was invented in the holiday by Guido van Rossum. R is for statistician, Python is for everyone else. And R has these pipes, while Python is like for this 4i and range, that never ending indentation war, which is quite challenging sometimes. Okay, so to conclude, I'd like you to think about what is learning to code means for someone that is just starting learning a coding language. So you might find it very easy or very difficult anyway. So you get started with starting writing something such as a hello world, and then after sometimes you learn what is a data frame, but then everything breaks down and you don't know. It seems like that you don't know how to do anything. That is what is called the impostor syndrome. And so, but then you finally meet the point and conclude your analysis. So it's a sort of roller coaster, the learning procedure of learning a new language, and you never end, because when you finish, you start everything back again. Okay, so I encourage you to learn Googling, because the key learning to code is like learning to Google like a pro. You find all answer, just don't memorize, bookmark, and use RStudio, Cloud, use Google Colab. These are very useful. And then I warmly suggest you to use ChatGPT or Copilot, which they help a lot. So the real skill is Googling well. Okay, so here just to show you a line of code for modeling. This is a linear regression model, which is frequently used within statistician. And we do this to like investigate the relationship within variables. And so in R, you will do LM. This is a function with inside Y that relates with X. So that's the formula, and this is the data. this is like it usually said that so Python executes systems. So it's a bit more there is an explanation. So what am I using? A linear regression function. It's not just LM. So I cannot, so a linear model or a linear regression function. And then there is this, whoops, what's happening? There is this dot that in R, it might be used even for names. You can just set a name of an object with a dot. While in Python, you cannot do that, because when you use a dot means that you are connecting to functions. So it tells you that you are actually doing something. Okay, so this is all I wanted to share with you today. I warmly suggest you to have a look at all the capabilities R would offer for you to make a map. And data visualization is still very strong within the R community, as well as we have other tools. But in R, they are very, when you finally release your visual, they are stable and they cannot be messed up. So, and they are visually very beautiful looking. Okay, thank you very much for your participation today. I appreciated your interest for R. And so what I suggest you is to keep an eye on our website, RLadies.rom.org. Even if you just Google RLadies.org, you find the international community. And stay tuned, because we are going to meet in person soon. And so you are very welcome. Thank you.
Thank you very much, Federica. Very nice talk. Are there any questions from, or just curiosities from the audience?
Yeah.
Yes, please. We don't have microphones, so you might also come here so that they can listen at all.
Vorrei chiedere come il Python viene usato, ad esempio, nelle ricerche.
Python viene usato sicuramente in diverse spazi, in diversi tipi di analisi. Immagino che in vulcanologia sarà usato per analizzare la distribuzione di condizioni climatiche varie e sicuramente sicuramente in molte altre.
So I will switch to English for the audience. Well, you're lucky enough because there are two colleagues which will give you some examples on how we use Python. As I told, INGV, it's quite broad. So we have volcanology, seismology, and anything that relates to the Earth and geophysical effects. So I cannot tell you precisely about volcanology and seismology, unfortunately, because I don't work there. I'm not even sure that they use just Python or some other languages. But for sure, what can I tell you from my perspective is that I use Python for pretty much from anything that goes from data analysis. So you have raw data, you want to analyze your data and try to uncover some patterns, or predictive stuff. You have a time series, you want to predict something, which is usually very difficult, especially when it deals with future stuff. So any kind of things you can think of, possibly Python can be useful. It's quite a general purpose language, so the only limit is your fantasy.
Grazie per la domanda. Ci sono altre domande che volete fare in particolare relativamente a RLadies, for example, or any other questions about community learnings? How do we learn? What we do? Why do we choose some topics more than others? Anything that you like to understand a bit more?
Just a curiosity, as an actuary, how do you use Python in your daily life? If you ever have to use Python.
Yeah, there are various. I mainly find Python used within studies that I search for my investigations, and so it's very important to me to be able to understand what
is literate.
What they.
Thank you very much.
Thank you.
Are there any other questions or curiosity? I ask, just come in. Oh.
I would like to ask, since it's a long time that I'm not using R, I use it during my bachelor degree, so like 10 years maybe. And I tried to apply some C++ or C within R. And at the time I didn't be able to do that. And I want to know if now it's possible to integrate some Python language within Airframe or not.
Yeah, absolutely. There is the company RStudio, is now POSIT. Just focusing more on multi-languages, and particularly within improving capabilities within the Python framework. And so they have released a tool which is called Positron, and it's visually quite the same as VS Code, but it is within, like, in the middle between RStudio and VS Code, and allows you to use R Markdown, which is now Quarto. Quarto is the advancement of R Markdown. And when you use that type of document to produce your analysis, you have chunks of code that you can use both in R and in Python.
That's amazing.
If you are interested in this, you can see we have just done a very quick introduction to Python for our users, where we show how to use both languages within an R Markdown document. So if you want, you can like check our website and you see what is that. Thanks for the question.
I guess in general, I mean, Jupyter environments are also meant for that, because Jupyter is for Julia, Python, and R.
Yeah,
so yeah,
that's not the reason.
Yeah, of course. I have even Jupyter allows you to.
Since
the language support.
I'm not.
I mean,
I'm more a backend developers.
Okay.
Thank you very much.
Thank you.
La cartella poi metto io, la lightning talk. So now it's time for lightning talks. We have at least 4 right now. I don't know if any one of you has something else you can write down here, or you can just stand up on the floor and you can tell us. So we can start. Okay, we can start with Marco, which will tell us about automatic detection of LSTID. He will tell you what LSTIDs are. using image processing techniques. Hopefully. Okay. Non è la più pallida idea.
Yeah, there's a typo here. Don't read it.
Yeah, it doesn't work if you're correct. No. Okay, so hi everyone. My name is Marco Guerra. I work here at INGV and I'm doing a PhD, and I'm going to present you this work, which is automatic detection of large-scale traveling ionospheric disturbances using GNSS data and image processing techniques. So I guess most of you don't know what the ionosphere is and what LSTADs are. It's not a disease, it's something interesting, at least for ionospheric physicists. So the ionosphere, it's a globally neutral plasma, which is, as you said, a layer of the upper atmosphere that goes from 60 to 1,000 kilometers. And total electron content, which is the measure that we use for our studies, is basically the integral of the number of free electrons along a ray path. In our case, from a receiver, a GNSS receiver, for example, the one that you have on your smartphone, and the GNSS satellite in orbit. And this total electron content, it varies with solar activity, time of day, and geographic location. And as I said, we derive it from GNSS. Large-scale TIDs, so the phenomena that we want to detect and measure autonomously, it's basically wave-like fluctuation in the plasma density that is traveling in the ionosphere. And in our case, these large-scale TIDs, they're generated by space weather, the thing that I was telling you about in the introduction. And these are triggered by auroral activity. So the auroras that you usually see in fancy photos online, it's basically the visual, let's say, pattern of the electrical currents that are generated in polar latitudes. And these are causing the appearance of these waves that are traveling towards the equator. So what is our objective is very simple, to me, at least from as an objective, it's kind of simple, is to develop an automatic detection algorithm. And so what is our data? We use GNSS receivers. We gather them as dual frequency RANX files, which are coming from a plate observatory system, which is called EUREF, which is a European network. And we have an issue, which is, okay, the animation aren't working on. So we have an issue. We have too many data to process. You can see that they are of interest of our study. And we have an uneven spatial distribution of stations. So our solution, and here comes the first Python implementation, is k-mean clustering. So it's we just wanted a very simple algorithm to find, we select a number of clusters, so 100, which gives us a good spatial coverage. And we select the 100 stations that are showing the best distribution. And here you can see in green, the station that we select, and in red, the ones that we discard. So this is the kind of image that I'm working with. This is 1 day measurement. We investigated 4 years of this image. So for like, if you multiply the number of days, that tells you the amount of images that we have. This is an example of LSTADs. You can see, so basically we remove the trend for the measurements, and you can see in red positive deviation and in blue negative deviations. So let's take in this, for example, which is simple. You can see that we have an oblique band in red and an oblique band in blue. So this is basically a wave that is propagating. On the y-axis, we have latitude. On x, we have time. So if something is oblique in this image, that means that something is propagating. All this black, this red and blue lines. This, I don't know what happened, sorry. So basically all these lines that you see are LSTADs. As you can see, there's also a lot of noise, which is represented by this signature, for example, or this, all these like random noise that you see around the image. As I said, this is a very clear example of LSTADs. So most of the time, there's no, as you can expect, there is no solar activity, there's no magnetic storms. And so usually we only have noise and not that many signatures. So how does our algorithm work? So we have the input as geogram images. We use binary masking. So we divide in blue and red, we have 2 different masks based on a threshold, which is non-zero to remove noise. And we want to identify connected regions. So connected regions are basically when 2 pixels are defined as connected if 1 pixel has a pixel of the same color, so red or blue, above, on the side, or diagonally adjacent to it. And we only retain regions that are elongated more than 10 degrees of latitude. 10 degrees is half the image. So basically, if the size of the connected region is half the amount of pixel on the y-axis. And then we refine the irregular regions that I'm going to show you later. These are the different colors are different connected regions. And then we refine the irregular regions. I'm going to show you what is an irregular regions with Bayesian Gaussian mixture model. And then we extract the speed. So basically, this is basically space-time plot. So the obliqueness of a region is basically speed. And after this, we do filtering. We know from literature that they have certain characteristics, and so we can remove all the ones that are not feasible according to the physics. So the refinement, this is an example of an irregular regions in orange, and you can see that we have two different bands that are connected together. So we obtain the convex hull with region props, and then we want to find if there's a large concavity. We use alpha shape to derive this is the convex hull. We derive the concave hull with the alpha shape, and then we check the maximum size of the largest concavity, and we apply Bayesian Gaussian mixture model to split the two regions. As you can see now, they are considered as two different regions. After this, I'm going to show you more or less how is let's say, the layout of the full chain of processes. We have the input, so the GNSS data. We process it with calculating total electron content, so the integral of electrons. We perform the trending with high pass and low pass filter, and then we generate the images that I showed you before. Then we do detection, so we try to find connected regions and we filter them, and we extract the features like period and speed and so on. And after this, we're going to have our output, which is a catalog of these waves appearing in the ionosphere. And it's really important to have this kind of architecture, so modular and step by step, because it's fully automated. So you just decide the time range that you want to study, and it does everything by itself. And since it's modular, we can change one of the, for example, we can change the trending technique. So basically to remove the trend from our data to try and find different periods of waves, or just if you want to filter different things, we can try to search for waves that are traveling towards the pole rather than towards the equator. And I think, okay. So that's all. I just want to spam you an event that I'm organizing with some friends of mine that are doing also machine learning and everything that's related applied in physics and science in general. And this event is gonna take place here on the 19th of September. You can scan the QR code to check the website. There is no submit. It's free of charge. So, but if you have an abstract, so if you want to propose something that you want to talk us about, you can do it, and we are gonna choose some of them to present there in this place. So feel free to submit something or just register to the event. Thank you, and I'm open to any kind of question.
It's technical, but if you have any curiosity, just you stare there.
Yeah, maybe. Mm-hmm. Which one? You mean this one? I mean, this is, okay, so to get this kind of image, it's a really long process. I mean, we have data that are in a very old-fashioned way of which are INEX files. So basically, we are specifically, I developed a library. Unfortunately, it's not in Python. I'm not gonna say in which code it is because yeah, we're working on that because let's say that in our field of work, let's say that half of the things are made in MATLAB, so no open source. And so now we're trying to change this to Python, but MATLAB is used to read all the files and do the training. And after this, we switch to Python because for machine learning and image processing, it's clearly better. And so basically, just to explain what I've done to obtain this image, you have all your, let's say we have something like, I don't know, I think it's around 50 million measurements per day of the ionosphere. And so basically we get all the measurements that are belonging to one pixel. So one pixel is representing one latitudinal slice for one given time. And so we merge all the measurements together and we will obtain a pixel. You do the same for all the pixels of this image and you obtain something like this. This is, as I said, this is the trended, but you could also do this. Because when you were saying about mapping, we have some people in this room that are working on the total electron content map. So basically, the INGV in the website that he was showing us before is providing European, world, and Italian maps of total electron content. So basically, in real time, with less than, I think, 10 minutes of cadence and delay, you can see the amount of electrons that are above your head in any given place of the Earth.
Thank you very much, Mark, again.
Thank you.
Now, Massimo, which will tell us about customer to Python-based web services. Aspetta che ci arrivo. Come? Sorry.
Okay, hello to everyone. I'll be more technical than Marco, maybe. And I am a fellow researcher for the INGV in the same group as Marco and Vincenzo, the upper atmosphere physics and radio propagation INGV group. And I'm more on data management and also programming here. And I show you what I did now last year. And I make it better this year, which is this custom SQL Python-based web service that is a simple API that I took from an old project. Old means like 4 years ago. That's now is old. But yeah, what is the aim of my project? Since okay, as a group, we have to manage this huge amount of data from receivers around the world. We have like both ionosomes that are just, let's say, radar to do vertical sounding, and also GNSS receiver that we use to see how the intensity of the signal, let's say, as it is conflicting with the ionosphere, apparent ionosphere. And also we have many processes and algorithms that from which we took the R3 data, we parse and store in databases. So the aim of the web service is to make available all this data that we collect in relational database that's now our PostgreSQL database. And also this data has to be open and unrestricted, and everyone, both researchers and stakeholders, have to access this data. So at first glance, we took this PHP web service to share this data. That was now is obsolete. It's difficult to integrate with modern tools. Yes, we have Kubernetes and Docker, so it's not a problem. But yeah, it cannot manage this very connection in the meantime, so it's not the best. It's slow and inefficient, and high query loads causes a lot of trouble. Sometimes we had all the database stopped since we have too many requests on inappropriate requests. So what are the goals? What was the goals of my project? Is to create a modular Python-based and extensible web service, for sure. Retain the same syntax. It was SQL. That is just a language a method to interrogate the API and to translate it in queries. And also we have to make available in the same format, JSON format, for all the response that we have. And also we have for sure improved performance, configurability, safety. We also had an hacker attack this year, so it's not the best. And also logging and that check, that was a little bit of trouble to manage it for the old one. And also for sure we have to make it very easy to integrate with other routes and whatever we want. So I choose to write it again from the beginning in Python 3.10 using a Flask framework. For deployments using Docker, Kubernetes, and Unicorn. For cache, I use flash caching. That's make able to use both simple cache, Redis on Memcache. I programmed some custom middlewares, both from managing the access from different IP or just to tracking some disaster events. Also, but for Epidocs, I use Flaskr, and for DB access, I use PsychoPG with PostgreSQL. I also try to make it as more configurable as possible. So I use both the file, the unicorn file for the configuration, but you can be able to configure it by a general configuration YAML file that also allows you to activate some middlewares that I developed. And also for each database from which you want to connect to, you have to write down a specific YAML for each database, in which also you can just select, I don't know, if you have a time series or a time scale DB, you can select the end time, start time, from which you can be able to do the request until that's you are to rule out. Also, I preserve the same filtering from the trickle one, and for the routing is a very simple one. You can from the home page you have the README as given as HTML. With the first one, you see the configuration that you have, and then you can interrogate both. Yeah, I know, Vincenzo. I know. You are terrifying. You're scaring me. And also you can both see how the tables are tables view and also table functions, since it's allowed also to interrogate table functions specifically, are structured, and also you can ask for the resource inside these objects. Yeah, now what I'm doing to integrate with other functionalities is to expanding it with another API to allow you to retrieve the files that we parse and store. That we have currently on NFS. So I'm trying to, I try to rewrite some of the watchdog functionalities to allow me to have better, better performance on NFS. And yeah, now I'm trying to write a class to read all the resources that I have in the database and make a proper Swagger file, since now the one that I did is not the best for my perspective. And now I'm also doing a Kubernetes integration for scalable deployment that written in Golang this time, so don't judge me. And yeah, and continuous integration tool for data stability. In the old Dust spec, I did a comparison between the old and new AWS. That's, yeah, I obtained like a 20 to 90% performance, better response time. Obviously, using Unicorn, parallel requests are boosting like double. And for the cold start time, I improve it at a few milliseconds, since it was like 1.5 second. Now I have 0.5 seconds. So yeah, that's better for sure. And thank you to all for the attention. You can go to my GitHub repo. I will, for sure, I will be able to make it better, I think, in the next few weeks, but I thank you.
Very technical talk, but definitely important and definitely very, very useful stuff. The kind
I
of
hope so.
that shouldn't see, but that really can make it worse. Other questions also?
I don't use connection points, so that's my fault.
Wondering, what's we are actually using for CIT. It's
Okay.
I mean, I don't know what using
For what?
continuous integration.
Okay, I don't know. You can both write down a bash file. Okay, to just to perform. I don't know. You have some config. You install. I don't know. Using Docker. You're supposed to use Docker Compose. Okay, you install a PostgreSQL database with a few tables, I don't know, okay? And you populate them by a SQL file that you can start by write down a command line, and then you can ask to the web service in localhost what is the answer that you expect to have. And then every time that you have to do some other push to the Git repo, you can perform the same test. Yeah, very, very basic one. But in Go, you can use Golang. Golang is better since it's integrated to GitLab. I don't know, example. Yeah.
I was just curious to know if
Yeah,
there
yeah.
was, like any orchestration to go.
Yeah, just an effective one. But we don't have much time to spend on, so I try to be as efficient as possible.
Thank you very much again.
Thank you.
Now it's time for Federico Palma, which will tell us about smart model, open source. I can read your writing.
Yes, go to the internet, to the GitHub page, because for me it's, because I don't have any slide.
Ok, possiamo andare, no, su col tuo PC?
Sì.
Ok, no, sto chiedendo, è un problema se c'è.
Di GitHub Smart Models, poi.
Aspetta che non sto dove. Sì,
Sì, perché sennò se
Andiamo.
parlo solo, poi fanno fatica.
allora aspetta.
Fatica pure a accettare.
Se puoi cercare, non so. Smart Models?
Sì, sì, basta
Ok.
mettere...
Non so cos'è.
Non ha voluto trovarlo? No, vabbè.
No, non so se cerca qui magari se...
Ma su Google conviene perché...
Vai su Google allora, dai, sì.
Sì, sì, no, ma basta fare... Models. Ah, vedi che Google non sbaglia mai. Però non è questo. Sì, sì, no, ma tanto se no ti vado a prendere, ce l'ho qua con me. Fa il portatore mia. Che fa così? E GitHub slash... Allora, se vado su github.com... Allora, se vai su github.com slash smart models proprio.
Sì.
Com, slash
Così? Vai.
smart tattino models. Eccolo.
Lui.
È lui.
Ok, proviamo un attimo a condividere allora. Se vai... Federica, non so come... Cioè dove... Proprio un giorno imparerò, ma non è questo il giorno, a usare il Mac. Per condividere questo.
Questo schermo qui?
Sì.
Sì, sì.
Questo, allora andiamo qua su Zoom e facciamo share e poi questo qua. Ecco.
Okay, so here we are.
Please, the floor is yours.
Okay, thanks for the passion. Thank you, Vincenzo, for inviting me. It's my first experience. I didn't prepare anything, but it's not a set, so I'll read very quickly. My name is Federico Palma. I am an engineer. I work in engineering IE. And this is my open source experience. Beside my job, I decided to launch a project completely open source based on Python, complete in Python. I suppose I'm in the right place today. And what is it? In the world of the generative AI, now everyone is speaking about the generative AI, there is one of the biggest problem is the hallucination of the models. Sometimes you ask something to, you can say ChatGPT, Anthropic is not important. And the result of this, of your question, the result is probably is not as you want. There is an hallucination because the system was trained with data, old, not pertinent to your question, and so on. So what's happened? How we sort out this problem? We sort out with REG. This is one of the most used service. REG is a retrieval augmented generation. So what's happened? We make a question. The system retrieve information somewhere else and put inside the prompt and give you the answer focused on the information you give it. In this case, this project is normatic semantic chunker. I don't want to go deeper in the technical field. It's not so important. What's happened? For example, we have a huge quantity of documents, technical documents. For example, the papers of Vulcanology and the seismography. So 1,000 of papers. And want to ask questions to your ChatGPT, for example, regarding these papers. The best thing is to take these papers, all of them, gigabytes of data, and put inside the prompt. But it's not possible because the prompt is small. It's not possible to pass the thousands and thousands of words. So you have to take only some chunks. The problem is you have to find this chunk inside of text, of course, inside a huge quantity of papers. And this techniques is to retrieve the chunker with a semantic system. So what's happened? It's not so complicated, and this is well-known techniques. You take your papers, you chunk, for example, 10 lines, and 10 lines, and 10 lines, and then you associate to this part of the text with a vector, the embedder. The embedder is a vector about, could be 100 or also up to 1,000 numbers in the vector. They represent the semantic of the text. For this, there is a semantic embedder, so you have to do anything. You have to apply a workflow. After that, when you ask for a question, this question is embedded, and you have a vector represent the semantic, and you search inside thousands of chunks. That chunks, they have the similar semantics, so the distance from the two vectors are very near. You take this part and go inside your prompt. Now, why normalize the semantic chunk? If you are a developer agent or generative AI, in Python, it's full of libraries. The most used are Llama Index or LangChain, where you will find easily class tools, libraries and classes to sort this problem. The problem is you have to write many lines code. You have to work a lot. My idea is to give to everyone in open source a system that's ready to use. The only thing you have to do, Docker Compose Up. Download Docker Compose Up, and you have a wonderful fast API endpoint with everything inside. Now, if you have time, you can go to my repository, read and use it because it's better to understand. You send the text in MD5 or 65 to the endpoint, waiting for the process some seconds, and you receive a JSON with all the chunks. The chunks are divided with a semantic roots, just a little bit elaborated, that here is explain everything. And the nice thing, there is also the acceleration with the GPU with CUDA. Besides this project, this is the first project of smart models. Yes, they were very fast. This is but the first project, there is others for this kind of things. Why I'm very glad to propose this project? Because this is open source and completely work on your PC. Because you can, your data, the privacy of your data. In all my projects, and this is the first one, for be sure your data will remain only on your PC. You have to move to OpenAI in the USA or something else. So you can process here using your PC, using a normal on your PC, like mine, and you send the text and add back the charts. Then you have to place them, put them inside the vector DB. So this is the first step, the first bit of the process. But this is the most important thing is this is ready for production, just a Docker composer. So, okay, thank you very much. And then you take the time to go to my project, download Docker Composer, and enjoy yourself.
Thank you very much, Federico. Definitely a try. Looks very nice. And also excellent talk. If you didn't prepare anything, it was just perfect. So congratulations. Other questions about, I don't know, to integrate this kind of thought in applications you have in mind?
I like the make it with ChatGPT.
Questions? So we thank you again, our speaker. And
okay, thank you very much.
thank you very much. We can now move on to the last speaker, designer, which will tell us about flying solid. If you will fly.
Allora,
Ce l'hai le slide?
te l'avevo mandato, non so se...
Ah,
cioè, l'ho messo su PyData.
Su Drive?
Okay, so while we prepare, some of us are going to have dinner later. So if you want to come with us, just write on the community Telegram group. If you are not on the group, after we finish, come to us.
We'll put you in.
Yeah, so you can.
Just a second.
Devo dire qualcosa.
Vabbè. Egon, floor is yours.
Okay, so this talk is called Flying Solidly, Python Design Principles Explained with Birds. So how many of you knows what solid principles are? Raise your hand. Okay. Some of us, probably the people that study informatics and are actually okay programmers or good programmers, from okay to good. And so I was not a good programmer. In fact, I was a shitty programmer for the first years of my career, since I studied economics and then data science. So I was an okay data scientist, but a shitty programmer. So if you are a shitty programmer or from shitty to okay programmer, maybe the solid principles are something that will help you. Solid principles are software object-oriented lifelines for state maintainable design. So it's something that this guy, Uncle Bob, a big guy in informatics, have to, it's like a, okay, it's a slogan, and these are 5 mnemonic guidelines that helps you to keep your code tidy, organized, understandable, reusable. So how your code have to be to scale up. So as long as your code base grows, these principles help you to maintain it clean. So first principle, a class should only have one reason to change and one responsibility. We are gonna see how Birds struggles if we violate the principle. So if you violate the single responsibility principle, in this case, we have a very big, a big class. It's not like how long is it, but it's the fact that this class does a lot of things. So this class bird is responsible of making the bird fly. It's responsible to make the DB save, printing things tidily, etc. And we see that this sparrow is really struggling because he has a lot of things to do. But the sparrow is happier if we, for example, we have a class bird that it's only responsible of the things that are really proper of the bird. So make him fly. And then we have a bird repository class and a bird card printer. So each class has one responsibility. Second principle, software entities should be open for extension, but closed for modification. So we should not have, for example, a function that, in this case, we have a flight speed in which each bird has a function. In this case, it's just returning an integer. So we have the sparrow, the eagle, and then this bird, I don't know how it's called, like Titi. If he wants to have this speed, we have to modify the function, and this is not really tidy. Instead, we should have an abstract class that we can import from ABC. Now we don't have time to explain abstract classes, but it's interesting. So we have an abstract classes in which that defines that the bird has to have a flight speed. So maybe we can extend it and have subclasses of birds, and we have sparrow, eagle, and if we have a new bird, we can just inherit from the abstract class. Third principle is basic of substitution. So subtypes must be completely substitutable for their base type without altering correctness. For example, if we expect that we will have some birds that cannot fly, for example, a penguin, we should not have a fly method in the abstract class bird, because otherwise the penguin that cannot fly will try to inherit it and die. Instead, if we want to have an happy penguin, we should have a class bird and a class flyable, or maybe a protocol or a mixin. We don't have time to go into that. And then we have, for example, a flying bird that inherits both from bird and from flyable. So we know that, for example, the seagull can fly and swim, for example, and the penguin can only swim. Fourth principle, interface segregation. Clients should be forced to depend on methods that they don't use. So we should keep interfaces small and specific. For example, we have the kiwi. It's a really stupid bird. It cannot do nothing. It cannot fly, cannot swim. He can sing, but it's just like beep. Okay. So we shouldn't burden the kiwi with the implementation of raising the fact that he cannot fly. Instead, we should have different abstract method or protocols. So, for example, flyable, swimmable, singable, and then we know that the kiwi inherits only from singable, and for example, the duck, a cooler bird, can do a lot of things, can fly, swim, and sing. The last principle is dependence inversion. So high-level modules should depend on abstraction and not on concrete implementation. So for example, if we have a class of worm dispenser, and then we have a bird feeder, we are putting the concrete worm dispenser in the abstract bird feeder. This is not really nice, and it's not clean, because otherwise, if we want to change so the bird feeder is the thing that gives the food to the bird. So it shouldn't implement what food the bird feeder is giving. So for example, we could have a worm dispenser, a seed dispenser, and an abstract class bird feeder. Then we know that when we initialize the bird feeder, we have to give a provider, but it can be each provider. So each bird can have his food and his. So thank you for the attention. Be a better programmer, because otherwise your code is not going anywhere. Okay.
I have a curiosity, if you don't mind. I guess that anyone works for a machine need to have background physics, so I never how to properly write some code effective and easy to read and stuff. So I'm just curious, what apart from the solid principle, what's important to you as well to become a good programmer?
Okay, so there are a lot of things. Some are more related to the work that we do and how you live, and other related to how you live your work. I start from the second now. For example, I started in a consulting company, and I was really just doing mainly the data science part. And at some point, it was not important or in that team, because in the company, maybe other people knew how to program, but in the team, there was not the culture. So at some point, if you are the best programmer in the room, well, change room. So what I did, it was, I changed company and I went in a different company in which there was some, the culture for programming well was better. So learn from the others, and then keep learning. So for example, if you are implementing something, or for example, I use Gradio. Okay, it's an open source library. Maybe somebody knows it. It's part from Hugging Face library, no? And I needed to do something a little bit stranger than the usual, and it was breaking. So what I did was I went to Gradio. I said, this thing doesn't work, and they say, okay, if you want, fix it. So in the end, it was just like an argument that was not passed well, but to understand that was the problem, I had to read a lot of code. And I say, okay, people knows actually how to code. This is really different from what I do. So in that way, you learn. So you have to keep reading code, and if you see something that you don't understand, you have to try to understand it and not say, okay, yeah. No, you have to go to ChatGPT, but you have to go to ChatGPT and say, solve it and explain it to me, not just solve it and try it. Yeah, because I mean, almost all my code now is written by ChatGPT, but it's important that you are, so accountability, it's something important. So you have to be accountable for that code, and you have to understand everything that you are pushing, because if you push something and you cannot explain it, you're a very bad person.
Do you write documentation?
Yeah, ChatGPT. Right. It's really right. Other questions?
Why the learn?
It was I don't know, because I think that it's from the penguin, for the penguin, because when I read about basic of substitution, this is the first thing that comes to my mind. So I say, okay, I have this ChatGPT, I have this idea. I want to make solid principle, for example, physical substitution with the bird. Give me all the bad code, all the good code, all the images, and then I'll do the talk. So you have just to have the idea and to check that you have to know what you're doing. Yeah. That's fine. Okay.
You have to know that Julio didn't know about Python and structure. One of learning Python from very basic.
Yeah, we forced it.
Yeah, we forced it. Of course, there was some output there. We are waiting for your next lesson. Here. Okay, so
Mettiamo i QR code. Fai, io cerco i QR code, tu parla.
be willing to share something, don't feel your side, anything that goes to say or you want to have the personal progress, feel free.
Il drive di PyData, così abbiamo tipo una slide con dei QR code. Anzi, mettiamo il sito, scusa, abbiamo il sito. Oops. Okay, now we have the website, so we can do that. Okay, so this is the website. You can find all our contacts. This should be the channel, but inside the description of the channel, you find the link for the community. Yes, so.
Just want to say that especially for the new faces here, we post messages on Telegram, on LinkedIn, you always have to sign up on Meetup if you want to participate to the events. We are also exploring with GitHub. There's nothing really important right now there apart from the website. Very important, if you want to propose a talk, feel free to do so there. And just, I don't know what else to say. Just feel free to reach out for anything. We are always waiting for your talks, your lightning talks at the next events that we are committed to do on a monthly basis. So just sign up and we will keep us posted. For tonight, for this evening, this is pretty much everything at INGV. But some of us are organizing to have dinner or an appetizer, well, an aperitivo together. So if you like, feel free to join. And I think that before leaving, we can all have a picture together here or maybe there. I don't know. If you like, we can just stand there and take a picture together. Thank you very much. Vorrei staccare la condivisione. And bye also to everyone at home.
Bye, everyone. Thank you.
Ciao.
See you
Thanks
next
for
time.
joining.